Howdy and welcome back. We'll continue our discussion with interfaces. So in the physical universe, we interact with a number of different objects through interfaces. For instance, when we go to turn on our car, we can simply press a button, or if you have an older model like I do, turn the key over and the engine will start. Interacting with the car through this interface, the button press initiates a whole sequence of operations that happen behind the scenes that actually invokes our car to start. This idea kind of stems from information hiding. Information hiding is accomplished by restricting access to data, functions, types, etc., in order to hide implementation details while providing the user with an interface detailing what the object does instead of how it does it. I think this is a good example here is the push button start or the key start of a car. Essentially, when we push the button, we know that the car should turn on. However, it does not tell us how that operation actually takes place. So for example, we start the car, but the details how this is accomplished are not of interest to us, and it can actually be hidden literally underneath the hood. You just turn the key and voila. Now getting back to kind of programming languages, user-defined type and information hiding. How's this related? Well, in a similar manner. What a user interacts with respect to the user-defined types is going to be an interface, which is going to communicate the set of operations that objects derived from that type blueprint can perform. This will be the allowable behaviors, the way we expect instances of the type to respond to different operations. The implementation is going to be behind the scenes. The user is not going to see that directly because they will be interacting with our objects through the interface. The implementation is going to be hidden and consist of an internal state representation. So the actual data members, we're not, unlike with the struct when we begin getting into classes, and both of these allow us to interact or introduce a user-defined type to our program. Classes are going to provide an additional layer for information hiding, which will allow us to hide the internal state of those data members. Furthermore, what we'll see here is there'll be different visibility of the function members declared within our class, or struct for that matter. What we could have is methods that are going to be visible as the interface, which the users will interact with, and then we can have private or hidden methods, which will be used to actually implement the interface. A set of representation invariants can be maintained by ensuring that as we interact with the object through the interface, that any sort of things that we always want to be true about that object can be preserved by all the methods. Here's an example of car in a simple driving game. The interface could be the ability for the user to specify that the car should go forward, reverse, left, right, to accelerate or brake. Allowable behaviors could be that the car can navigate anywhere if the car has not crashed, and in terms of where that car is, we continue to just use its most recent position. The internal representation could be, say, the actual coordinates of that position, the speed in miles per hour or kilometers, the bearing, which direction it's going, as well as a maximum speed that car could not exceed. Representation invariant could be that whenever we interact with objects of our car type through the interface, the speed will always be between, say, 0 and the maximum speed. And this would be irrespective of what interface operation you're applying to our car object. We would ensure that all these functions respect this invariant on speed. There's a number of different invariants that we could incorporate into a user-defined type. This is one example here. And then obviously, we want to divide and conquer with functions. So a lot of these functions that are going to implement the behaviors visible to users of our type will be implemented using a number of methods that the user is not able to see. So why should we use user-defined types in our programs?